From concept to reality, how Helion's $5.4 billion investment is shaping the future of nuclear fusion technology.
Introduction.
Helion Energy, a pioneering company in the nuclear fusion sector, has recently captured significant attention by announcing a substantial $425 million Series F investment round. This funding round has propelled Helion's total valuation to approximately $5.425 billion. With participation from prominent investors including Lightspeed Venture Partners, SoftBank Vision Fund 2 and previous backers like Sam Altman and Nucor, this investment reflects a strong confidence in Helion's vision to transform energy production through advanced fusion technology.
Key developments and timeline. 1. Investment and valuation. As of January 28, 2025, Helion disclosed the successful completion of its Series F funding, which is part of a broader strategy aimed at accelerating the commercialization of its fusion technology.
The cumulative investment in Helion has now surpassed $1 billion, indicating robust investor interest and confidence in the company's mission to deliver clean and abundant electricity through nuclear fusion.
2. Technological advancement.
Helion has made significant strides in developing its fusion prototypes. The company is currently operating its 7th-generation prototype named Polaris, which is anticipated to produce the first electricity from fusion. The previously operated Trenta prototype achieved a pivotal milestone by reaching a fuel temperature of 100 million degrees Celsius, a critical requirement for commercial fusion reactors.
3. Market position and future plans. Helion plans to establish its first fusion power plant in Washington state.
The company has secured a power purchase agreement with Microsoft, which aims to supply electricity from a planned 50 MW fusion plant expected to be operational by 2028. Furthermore, Helion has an agreement with Nucor for a larger 500 MW plant anticipated for development in the 2030s.
4. Vision for fusion technology. David Kirtley, Helion's co-founder and CEO,
has articulated the company's commitment to rapidly developing and deploying safe, reliable fusion generators. The combination of investment and technological milestones positions Helion as a front-runner in harnessing fusion as a viable energy source, potentially influencing global energy dynamics and addressing rising electricity demands.
Common themes across sources. Investor confidence.
Across various reports, a consistent theme is the strong backing from high-profile investors, reflecting a collective belief in Helion's potential to lead in the fusion energy market.
Technological milestones.
The achievement of crucial temperature thresholds and the operation of advanced prototypes are consistently highlighted as significant steps toward commercial viability.
Future projects.
Helion's planned partnerships with major corporations like Microsoft and Nucor illustrate the company's proactive strategy to establish a foothold in the energy sector.
Differences in coverage. Source variation.
While sources such as Reuters and Helion's official site provided detailed financial and operational updates, access to GeekWire was restricted, limiting the diversity of perspectives available on the topic.
Depth of technological insight.
Helion's own announcements emphasize the specifics of its technology and future plans more than other sources,
which may focus more on investment implications and market analysis. Conclusion.
Helion's $5.4 billion investment and the recent Series F funding represent a crucial step toward realizing the potential of nuclear fusion as a mainstream energy source. With promising technological advancements and strategic partnerships, Helion is well positioned to transition from concept to reality, potentially revolutionizing the clean energy landscape in the years to come. The ongoing developments in fusion technology underscore the urgency and significance of this field in addressing global energy challenges.
Comprehensive overview.
The journey of Helion Energy is a remarkable example of how innovative technology combined with strategic investments can pave the way for transformative changes in energy production. With this significant financial backing, Helion is not only poised to enhance its research and development efforts but also to navigate the complex landscape of energy regulation and market entry.
Investment insights.
The $425 million Series F investment round marks a pivotal moment for Helion as it seeks to scale its operations and expedite the development of commercial fusion power plants. The involvement of prestigious investors such as SoftBank and Lightspeed Venture Partners not only provides Helion with the necessary capital but also with a wealth of experience and networks that can facilitate its growth.
Ravi Matre, managing partner at Lightspeed Venture Partners, noted the transformative potential of fusion technology for both industry and society,
expressing confidence in Helion's leadership and technological advancements. Such endorsements from seasoned investors signal a broader recognition of the urgency in developing sustainable energy sources.
Technological breakthroughs. Helion's advancements in fusion technology are particularly noteworthy.
The company's Polaris prototype represents a significant leap forward in fusion research,
as it is anticipated to demonstrate the first electricity generation from fusion reactions.
Achieving and maintaining the critical temperature of 100 million degrees Celsius is a monumental task and positions Helion as a leader in the quest for practical fusion energy. These technological milestones not only highlight Helion's capabilities but also serve as a promising indication for the future of nuclear fusion. The ability to generate electricity from fusion could provide a game-changing solution to the world's increasing energy demands while minimizing environmental impact.
Strategic partnerships and future plans.
Helion's strategy to establish its first fusion power plant in Washington state is a calculated move to enter the energy marketplace effectively. The power purchase agreement with Microsoft is particularly significant,
as it aligns Helion with a major corporate player committed to sustainability.
This partnership not only ensures a customer for Helion's future energy output but also enhances the company's credibility in the eyes of potential investors and partners.
Additionally, the planned collaboration with Nucor for a larger 500 MW plant underscores Helion's ambition to scale its operations rapidly.
These strategic partnerships will be crucial as Helion navigates the complexities of bringing fusion technology to market, particularly in regulatory environments that are often challenging for new energy technologies.
Implications for the energy sector.
The implications of Helion's developments in fusion technology extend far beyond the company itself. The successful commercialization of fusion energy could drastically alter the energy landscape, providing a clean, virtually limitless source of power. This could play a critical role in addressing climate change, reducing reliance on fossil fuels, and ensuring energy security for nations around the globe. As the world grapples with the challenges of climate change and energy sustainability, the advancements made by Helion and similar companies are more important than ever. The transition from traditional energy sources to innovative solutions like nuclear fusion is essential for achieving long-term environmental and economic goals.
Final thoughts.
Helion Energy's journey from concept to reality demonstrates the potential of innovative technologies to reshape our energy future. With substantial investments, significant technological breakthroughs, and strategic partnerships, Helion is setting the stage for a new era in energy production. The company's commitment to developing safe and reliable fusion generators aligns with global needs for sustainable energy solutions, making it a key player in the quest for a cleaner, more efficient energy landscape. As Helion progresses toward its ambitious goals, the world watches closely,
hopeful for the dawn of a new energy revolution driven by nuclear fusion technology.
The discussion surrounding Helion Energy's recent $425 million Series F investment and its total valuation of approximately $5.425 billion reveals several counterintuitive aspects of the nuclear fusion landscape. 1. High valuation amidst technological uncertainty. While Helion's valuation at over $5 billion is impressive, it stands in stark contrast to the historical skepticism surrounding nuclear fusion. Many experts have long considered fusion technology as the holy grail of energy production, often citing its technical challenges and the lengthy timelines historically associated with achieving commercial viability. This high valuation suggests that investors are willing to overlook traditional timelines and uncertainties, betting heavily on Helion's potential to achieve what many have deemed impossible.
2. Investor confidence versus market reality. The backing of prominent investors such as SoftBank and Lightspeed Venture Partners might imply a near-term realization of fusion energy solutions. Yet the reality is that fusion technology has faced decades of delays and underperformance in experimental settings. The investment reflects a belief in Helion's unique approach rather than a consensus that fusion is just around the corner, highlighting a disconnect between investor optimism and the pragmatic challenges of fusion energy development. 3. The commercialization timeline. Helion's plans to deliver electricity from a 50 MW fusion plant by 2028 and a larger 500 MW plant in the 2030s might seem aggressive given the historical context of fusion projects. Typically, such advancements take decades. This accelerative timeline could be perceived as an unrealistic optimism that does not fully account for the complexities of regulatory approvals, technological scaling, and infrastructure development needed to support fusion energy. For a public perception of nuclear energy, the general perception of nuclear energy tends to be negative, associated with risks of radiation and catastrophic failure, primarily linked to fission reactors. However, Helion's focus on fusion, often viewed as a safer alternative, contradicts this perception. The notion that nuclear fusion could be embraced as a safe, clean energy source is counterintuitive given the historical context of nuclear energy, but reflects a changing narrative that emphasizes the potential benefits of fusion technology. 5. Technological milestones and their significance. Helion's achievement of a fuel temperature of 100 million degrees Celsius is a critical milestone, yet it raises questions about the practical implications of such advancements. While reaching this temperature is necessary for fusion, the process of maintaining it, efficiently converting that energy into electricity, and developing the necessary infrastructure remains a challenge. This gap between achieving milestones and translating them into usable energy underscores the complexities involved in fusion technology that are often glossed over in investment discussions. 6. Strategic partnerships. The agreements with Microsoft and Nucor to purchase electricity from Helion's future plants suggest a strategic alignment with tech and industrial giants, potentially indicating a shift in energy procurement strategies. However, this reliance on large corporations as early adopters also reflects a counterintuitive dependency on a few major players to validate and support a technology that is ostensibly aimed at widespread energy democratization. 7. Environmental impact and market dynamics. While Helion aims to provide zero-carbon electricity, the broader implications of nuclear fusion on energy markets are not entirely clear. The notion that fusion could solve energy crises may oversimplify the complexities of energy markets, regulatory frameworks, and public acceptance, suggesting a potentially uneven playing field where fusion competes against established renewable sources, each with their own unique challenges and advantages. In summary, while Helion Energy's progress and investment may suggest a bright future for nuclear fusion, the underlying complexities, investor sentiments, and historical challenges present a more nuanced picture that challenges conventional expectations regarding the timeline and feasibility of commercial fusion energy. Overlooked insights from Helion's investment report. Helion Energy's recent $425 million Series F funding round and its overall valuation of $5.425 billion have captured significant attention within the energy sector. However, several critical aspects of this development may not receive the scrutiny they deserve. Below are key overlooked insights and their significance. 1. Investor composition and strategic implications. While the headline figures regarding funding and valuation are widely reported, the composition of Helion's investor base is often glossed over. The participation of high-profile investors, including SoftBank Vision Fund, Lightspeed Venture Partners, and existing backers like Sam Altman, is indicative of a robust belief in Helion's long-term vision.
Significance: this diverse investor base not only brings capital but also strategic guidance and networking opportunities that could be crucial for navigating regulatory landscapes and technological challenges. The presence of major venture capitalists suggests confidence in Helion's business model and market potential, which may enhance Helion's credibility in partnership negotiations with corporations and governments.
2. Technological milestones as indicators of viability.
Helion's achievement of reaching critical temperatures necessary for fusion 100 million degrees Celsius is a pivotal milestone that deserves more attention. While it is mentioned in reports,
the implications of this achievement are often understated.
Significance: achieving such temperatures is more than just a technical hurdle, it represents a tangible step towards commercial viability. This milestone indicates that Helion is not merely in the theoretical phase of fusion technology but is progressing toward practical applications. The ability to produce electricity from fusion could redefine energy production, potentially offering a near-limitless source of clean energy.
3. Partnerships with major corporations.
The agreements Helion has secured with companies like Microsoft and Nucor are often framed as mere business contracts.
However,
these partnerships are significant indicators of market confidence in fusion technology. Significance: these collaborations suggest a shift in how major corporations view energy sourcing. Microsoft's commitment to a 50 MW fusion plant and Nucor's agreement for a 500 MW plant showcase a proactive approach to adopting innovative energy solutions. Such partnerships could serve as a model for future corporate energy strategies, potentially leading to widespread adoption of fusion technology across various sectors. 4. Regulatory landscape and policy impact. The report touches upon Helion's plans for its first fusion power plant in Washington state, yet it often overlooks the complexities of regulatory approval and public policy implications surrounding nuclear fusion. Significance: the path to commercializing fusion power is fraught with regulatory challenges that could slow down progress. Understanding how Helion navigates these complexities, including obtaining necessary permits and adhering to safety regulations,
is crucial.
Successful navigation could set precedents that facilitate the broader acceptance and implementation of fusion technology, influencing energy policy on a national and global scale. 5. Market positioning relative to competitors.
The narrative surrounding Helion often positions it as a leader in fusion technology without sufficient context regarding its competitive landscape.
The emergence of other players in the fusion sector, such as TAE Technologies and Commonwealth Fusion Systems, is not adequately addressed. Significance: understanding Helion's unique positioning among competitors can illuminate its strategy for maintaining a competitive edge. Factors such as proprietary technology, scalability of operations, and speed of development will play a crucial role in determining whether Helion can sustain its lead. Analyzing these dynamics can provide insights into the future of the fusion market and potential shifts in leadership. 6. Public perception and acceptance of fusion energy. While the technological feasibility of fusion is essential, public perception and acceptance are often neglected in discussions about Helion's future. Significance: public opinion can significantly influence regulatory frameworks, funding opportunities, and the general market environment for emerging technologies. If Helion can successfully engage with communities and stakeholders to build trust and acceptance of fusion energy, it could pave the way for smoother project implementation and greater public support for future energy initiatives. 7. Global energy dynamics and environmental impact. The report mentions Helion's potential to influence global energy dynamics but fails to elaborate on the broader implications of nuclear fusion for environmental sustainability and climate change. Significance: as the world grapples with climate change and the urgent need for sustainable energy sources, fusion technology presents a compelling solution that could drastically reduce carbon emissions.
By focusing on the environmental benefits of fusion, Helion could align its mission with global sustainability goals, potentially attracting additional support from governments and environmental organizations.
8. Long-term vision beyond initial projects. Helion's immediate focus on its first power plants is often highlighted, yet the long-term vision for scaling and expanding its technology is less frequently discussed. Significance: the ability to scale fusion technology to meet increasing global energy demands is critical for its success. Helion's strategies for expansion, including potential international collaborations or adaptations of its technology for various markets, will be essential in shaping its future trajectory. Understanding these long-term plans can provide a clearer picture of how Helion intends to position itself as a leader in the clean energy revolution. Conclusion: Helion Energy's advancements in nuclear fusion technology and its significant investment round represent a crucial turning point in the pursuit of clean energy solutions. However, by delving deeper into the overlooked aspects of investor dynamics, technological milestones, regulatory challenges, public perception, and competitive positioning, a more comprehensive understanding of Helion's potential impact on the energy landscape can be achieved. Recognizing these elements is vital for stakeholders, including investors, policymakers, and the public, to fully grasp the implications of Helion's journey from concept to reality in the realm of nuclear fusion technology. 1. Significant investment and valuation. Helion Energy's recent $425 million Series F funding round, which elevates its total valuation to approximately $5.425 billion, underscores the intense investor confidence in nuclear fusion as a viable energy solution. The participation of prestigious investors like SoftBank Vision Fund 2 and Lightspeed Venture Partners indicates a strong belief in Helion's potential to innovate and lead in the energy sector. This substantial financial backing not only demonstrates the market's optimism regarding fusion technology but also provides Helion with the necessary resources to accelerate its commercialization efforts. 2. Technological advancements. Helion's technological milestones, particularly the operation of its 7th-generation prototype Polaris and the achievement of a critical fuel temperature of 100 million degrees Celsius by its Trenta prototype, are pivotal in the journey toward commercial fusion energy. These advancements highlight Helion's capability to break through traditional barriers in fusion technology, positioning the company as a front-runner in the race to make fusion a practical and scalable energy source. The successful demonstration of electricity generation from fusion could serve as a significant validation of the technology. 3. Strategic partnerships and future projects. Helion has entered into strategic agreements with major corporations such as Microsoft and Nucor, showcasing its proactive approach to establishing a foothold in the energy market. The power purchase agreement with Microsoft for a 50 MW fusion plant by 2028 and a collaboration with Nucor for a larger 500 MW plant demonstrates Helion's commitment to not only developing technology but also translating it into operational projects. These partnerships are crucial for building credibility and facilitating the transition from research and development to market implementation. 4. A vision for clean energy transformation. Helion's leadership, particularly CEO David Kirtley, emphasizes a clear vision for the future of nuclear fusion as a safe, reliable, and abundant energy source. The company's mission to provide unlimited clean electricity aligns with global energy demands and the urgent need for sustainable solutions to combat climate change. Helion's advancements in fusion technology could potentially transform energy dynamics, making it a key player in the future energy landscape and addressing the pressing issue of rising electricity needs globally. 1. The Manhattan Project 1942–1946. One of the most notable historical cases of significant investment and rapid development in nuclear technology is the Manhattan Project, a secret U.S. government research project during World War II aimed at developing atomic bombs. The project involved extensive funding and collaboration among various scientific institutions, leading to the successful detonation of the first atomic bomb in 1945. The Manhattan Project not only transformed warfare but also initiated a new era of nuclear energy and technology. 2. The Apollo Program 1961–1972. Another significant historical case is the Apollo program. which was a series of missions conducted by NASA with the goal of landing humans on the Moon and bringing them safely back to Earth. The program represented a massive investment in technology research and development, culminating in the successful Apollo 11 mission in 1969. The Apollo program showcased how substantial investments in science and technology could lead to groundbreaking achievements and advancements in aerospace engineering and related fields. 3. The ITER Project 1985-present. The International Thermonuclear Experimental Reactor ITER is a multinational nuclear fusion research and engineering project currently being built in France. The project aims to demonstrate the feasibility of fusion as a large-scale and carbon-free source of energy. ITER represents a significant investment from multiple countries, and its goal is to overcome the scientific and engineering challenges of nuclear fusion. Similar to Helion's efforts in developing practical fusion technology, the ITER project is seen as a crucial step towards the long-term goal of achieving sustainable fusion energy for global use. Future outlook, predictions for Helion Energy and nuclear fusion technology. As Helion Energy continues to push the boundaries of nuclear fusion technology with substantial investments and technological advancements, the future of energy production is poised for a significant transformation. Here are key predictions regarding Helion's trajectory and the broader implications of nuclear fusion technology over the coming decades. 1. Commercialization of fusion power by 2030s. Helion Energy's ambitious plans to have its first fusion power plant operational by 2028 indicate a strong likelihood that fusion energy will transition from theoretical models to practical applications within the next decade. Following the successful operation of its Polaris prototype, Helion is expected to refine its technology further, leading to a commercially viable fusion power plant. By the early 2030s, we could see multiple fusion plants in operation, globally revolutionizing how electricity is produced. 2. Widespread adoption of clean energy sources. As Helion's fusion power plants begin to generate electricity, they will contribute significantly to the global shift toward clean energy. Fusion energy, being a zero-carbon source, will play a crucial role in meeting international climate commitments and reducing reliance on fossil fuels. By 2040, it is plausible that fusion could account for a notable percentage of the global energy mix, especially as governments and corporations strive to achieve net zero emissions. 3. Economic growth and job creation in the energy sector. The expansion of the fusion energy industry will likely spur economic growth and create jobs in various sectors, including engineering, manufacturing, and research. As Helion and similar companies scale up operations, there will be a demand for skilled labor, leading to the development of specialized training programs and educational initiatives. By the 2030s, tens of thousands of jobs could be generated in the burgeoning fusion energy sector, contributing to local and national economies. 4. Technological innovations driven by fusion research. The pursuit of nuclear fusion will catalyze advancements in various technologies, including materials science, energy storage, and plasma physics. These innovations will have spillover effects, potentially leading to breakthroughs in other industries such as medical technology, aerospace, and telecommunications. As Helion and its competitors invest in research and development, we can expect new technologies and methodologies to emerge, enhancing efficiency and sustainability across multiple domains. 5. Global energy security and geopolitical dynamics. The successful commercialization of fusion energy could shift geopolitical dynamics significantly. Countries that lead in fusion technology development, like the US with Helion, may gain a competitive edge in global energy markets. As fusion becomes a viable energy source, nations may seek to collaborate on fusion projects, leading to new international partnerships and treaties focused on shared energy goals. This could foster a more stable global energy landscape, reducing conflicts driven by resource scarcity. 6. Integration with renewable energy sources. Fusion energy is expected to complement existing renewable energy technologies such as solar and wind. The ability of fusion power to provide a stable and continuous energy supply will be crucial in addressing the intermittency issues associated with renewables. By the 2040s, an integrated energy grid that combines fusion solar, wind, and energy storage solutions could become commonplace, optimizing the use of diverse energy sources to meet demand efficiently. 7. Public perception and acceptance of fusion technology. As Helion and other players demonstrate the safety and reliability of fusion energy, public acceptance is likely to grow. Educational campaigns and successful pilot projects will help demystify fusion technology and alleviate concerns surrounding nuclear energy. By 2035, we may see a strong public consensus on the necessity and benefits of fusion energy, paralleling the rising demand for sustainable energy solutions. 8. Investment trends and financial viability. The initial investments in fusion technology, including Helion's $5.4 billion valuation, indicate a growing confidence from investors in the sector's potential. As technological milestones are achieved, we can expect a surge in funding from both private and public sectors, facilitating further research, development, and deployment. By the late 2020s, fusion energy could reach a financial tipping point where it becomes competitive with traditional energy sources, spurring widespread adoption. Conclusion. The future of nuclear fusion technology, particularly through the efforts of Helion Energy, appears bright and transformative. As we look toward the next 2 to 3 decades, we can anticipate significant developments in energy production, economic growth, technological advancements, and global energy dynamics. The journey from concept to reality in fusion technology not only holds the promise of a sustainable energy future but also represents a pivotal chapter in humanity's quest for clean, abundant power.